Yo, what's up, guys? Welcome back. I think it's episode 124 today. Let me just make sure. 123, 124. Yep. We got a Jinx today. Let's take a look at the Jinx Pokemon sound. It's definitely a tough sound. What does that sound? But yeah, let's get straight into our problem. Zero Array Transformation 3. Might as well take a look, I guess. Given initial array nums of 2D array queries with queries ILI. Decrement the value at each index in the LI, RI in nums by at most 1. At most 1. The amount by which the value is decremented can be chosen independently from each index. A zero array is an array with all elements equal to 0. Decrement the value at each index in the range LI, RI in nums by at most 1. So what, you can do it by like 0.5? Like what? Okay. So we're removing the queries. That's what we're doing. Okay. Sort the queries. We need to greedily pick the queries with the farthest ending point first. Yeah. Try to think about the way to solve this. This is a really tough problem. So we need to sort the queries, greedily pick the largest distance, right? Then keep applying the operations until... But I think when we looked at this one the other day, total array transformation 1. This is the difference array approach. So I guess we can kind of reuse this code, right? Because we can't do the brute force method, because the brute force method would be an n squared loop, and it doesn't accept that. 10 to the power of 5. So my goal, I don't know if this will work, will be we sort queries. Okay. And then we pick them, we sort them based on their distance, right? So sort based on distance, right? We can loop through our queries for I in queries. Okay. We can do, well, AB is equal to I. Let's make a new res, right? Okay. And then we store, in that res, we store B minus A, right? Let's do res.append. And we append B minus A. I don't know if I'm cooking here. I might not be. It's probably maybe terrible solution or a terrible pathetic attempt, but it's alright. I mean, it's all about learning, so. Okay, so now we're sorting the distances, right? Okay, so now we do. Now we got the distances. So now I'm thinking we sort this array based on the distances. I think the best way would probably be a lambda function. Lambda function, Python. Whoa, syntax. I think I will always find lambda functions in Python super confusing, like their syntax. How to write a lambda function that takes AB takes a 2D array queries 0 to 1 1 and sort it based on the difference between B minus A. Okay, well that lambda function was a lot easier than I kind of thought. We do queries dot sort key is equal to lambda x and x1 minus x0. And then let's print out queries. Okay. Well, how do we... reverse is equal to true. That's what I couldn't remember though. Reverse is equal to true. So now we're printing... So now we got the most expensive query we're greedily picking the most expensive query, right? Then we want a loop, right? We want to take a look at the zero array transformation, which I struggled with a couple days ago when we wrote this code, right? We want to create the difference array, which is equal to 0 times the length of nums minus 1 for LR in queries. Okay. Plus or equal to 1. Diff array R plus 1 minus equal to, oh my gosh, dude, minus equal to 1. So we have our difference array. Print our difference array. Maybe the difference way won't work. For LR in queries, right? So we loop through 0 and 2. I just don't really think this difference array method is going to work. Alright, so we can loop maybe. Right here, I think it's kind of simple. I think we can do well for A and B in queries, right? Speed brute force method. We would do AB. We would go, okay, so for I in range length nums. Okay. We start at A and go to B. A and go to B. We would do, okay, well, if nums I is greater than 0, then nums I minus or equal to 1, else we would just continue, right? I guess we don't even need this else. I guess if it's 0, we don't do anything. Then we would do, okay, well, nums 0 is equal, oh, let's do, sorry, res is equal to 0 times the length, 0 times the length of nums, right? We loop through, do -1, then we would check, well, okay, outside of this for, and check, okay, well, if nums is equal to res, then we would return the length of nums let's do it inside of this if, actually. Turn the length of nums minus I. Right? Otherwise, outside of this loop, we would return -1. Print A, print B. I'm not sure why this wouldn't submit. 33620 array transformation 3. Why is this brute force method not working? Okay, so we're gonna need a copy and is equal to length of nums, right? We sort for index AB in queries. Okay, AB for I in range AB. If cur I is greater than 0, then cur I is equal to 1. Right, because we're mutating while we're looping. That's why it's not going to work. Okay, so is equal to 1 if cur is equal to res, turn IDX plus 1 plus I plus 1, return minus 1. Oh. Why IDX plus 1? Plus 1 because we start at 0. Here we use 2 queries. Like, cur I minus return or negative 1. AB enumerate queries. Why is this not working? I'm getting the incorrect. Not passing test cases. Damn, I thought picking picking the most expensive one that covers the most range. Or returning negative 1. I don't understand, like. Okay, yeah, I don't know. I would have thought this would work, dude. Just, So here they use Alright, we're gonna skip this one. This is a tough problem. At least we attempted it, we looked at it, thought about it. Let's check out a study plan. Top 100 best rated problems. Binary tree, dynamic programming, graph, greedy, hashing. We've done most of these problems, man. Like, search suggestion system. Minimum number of arrows to burst balloons. Combination sum 3, house robber. I guess we can do this one. Nth Fibonacci number. What is a Fibonacci number? Fibonacci sequence is defined as follows. T0, T1. I actually have no idea what a Fibonacci number is. Fibonacci sequence. Fibonacci sequence is an integer sequence similar to the Fibonacci sequence, but instead of each term being okay. Backtrack. We want to start it in, right? We want to call that backtracking function n. Okay. Then we want to do. We have to start top down, right? So. Or do we start at 0? No. I feel like no. We're only given. One 137 nth Fibonacci number. Do we? How do I ask my question? Do we? Question is like, do we begin top down? Um. If n is equal to 0, we return. If n is equal to 1, we would return. Right? What are we counting? Are we counting the recursion loop? I feel like that's the only thing I can think of. Like, let's make a non-local non-local count. Count is equal to 0. We'll keep looping. No, we wouldn't want it in here. I'm confused. What are we counting? Instead of 2. Return 0. Return 1. But since we have a third one, I think we're doing if n is equal to 2, we would return 1 as well. And then we would literally just call Fibonacci n minus 1 plus Fibonacci n minus 2 n minus 2 plus Fibonacci n minus 3. Instead, we would need a return. Then we would call the our backtracking method with n. Was invalid syntax. Backtrack n. Why are we getting invalid syntax? Oh shit, okay. I'm spelling it wrong. Oh. Backtrack. Whoops, not Fibonacci. Getting null. I don't know. What are we doing wrong? Oh my god, it's because we're not returning. I always forget to return here, bro. Like, every time. Okay. So this should fail. To be honest, man, I had absolutely no idea what I was doing here. Literally on the internet, I just had to think about it like Fibonacci. And with Fibonacci, this is like literally the exact same approach. Okay, right. So now we add DP here. So we go, okay, we add this. Right? Return 0, return 1. If n in DP, we would return DP n. Otherwise, we would return val, is he? DP val DP n is equal to val. We will return DP n. There we go. This should be our. There we go. That was close. That was definitely a little confusing. I'm gonna take a break here. I have to go to the bathroom, and I will be back in a second. Okay, I'm back. Let's take a look at online stock span. Oh, we're designing here. Okay. Design algorithm that collects daily price quotes from stock and returns the span of that stock's price for the current day. The span of the stock's price is 1 day is the maximum number of consecutive days starting from that day and going backward for which the stock price was less than or equal to the price of that day. For example, if the price of the stock in the last 4 days is 7212. Price of the stock today is 2. Then the span of today is 4. Because starting from today, the price of the stock was less than or equal to 2 for 4 consecutive days. Okay. I got self.stack is equal to this, right? Tonic stack. Self.stack. Okay, so let's do, well, if self.stack So if there's nothing inside of the stack, if not self.stack, we would self.stack.append if not self.stack, I guess we would just self.append 1. Self.stack.append maybe we might need 2 arrays or something. Res.append price. You know, I'm not sure about this one. I'm thinking about it in the wrong way. It should be, okay, well, if there's something in the stack and stack minus 1 is less than or equal to price. Alright, we have our span, which is equal to 1, right? Because we get this day. Then we would do if stack and stack minus 1 is less than or equal to price. Okay, then we would do, well, span plus or equal to self.stack.append. We can append the price and the span. Span is equal to 1. Okay. If self.stack and self.stack minus 1, 0 is less than or equal to price. We do that. We do that. And we would return our span. Right? I think this should be a while. We think about this in the wrong way. We should have thought about it like this first. Okay. Should we look at maybe one more problem? I mean, how long have we been going for? Shit, not very long. How about we take a look at this problem again? This backtracking problem. We've done it a little while ago, but let's see if we can do it. We did this one, I think, a few weeks ago. April 17th, so it's been about a month. This is one of the first backtracking problems we did about a month ago, given a string to dynamically represent all the possible letter combinations that represent AD digits is equal to 2. So AD, AE, AF, BD, BE, BF, CD, CE, CF. Oh, 23. Okay, how will we do this? Give it a string. You know. So 2 maps to A, B, and C, right? So we get A, we get B, we get C. And then we have D, A, D, A, E, A, F, B, D, B, E, B, F, C, D, C, E, C, F. Okay. So can you make a dictionary with phone letter combinations in Python. Because I don't want to type it myself. Here we go, dude. That is what AI is good for. Do not want to type it that myself. Phone letters 3, 4, 5, 6, 7, 8, 9. Def backtrack. Okay. We obviously need our combination, right? So we would pass in our digits combination. Let's call backtrack digits, right? So once we get our digits, what is digits? Digits is a string. So I think we would go, okay, so for I in digits, okay, then we do, I think we would need some sort of res array, right? Trying to think here how we can do this. If digits I if I in I feel like we'd probably need some sort of current or something, right? Okay. And then if the current if the length of current is equal to the length of digits, right? Then we know, right? And we would return, so we would do res.append code.copy and then return, right? So this would be our base case, right? Otherwise, we would loop through, so for I in digits, we would do code.append I no, we would probably have to keep track of the I too. Right, because I can't really think right now, dude. Like, the recursor case here to the digits and append code auto append I, right? Then we would check the length of the cur. I don't know. The thing I'm confused about is that when we access from the for loop, we access ABC. How do we append ABC into 4 different ones? That's the difference. I don't know. I just don't know. Res.append. For I in digits. Actually, yeah, this should probably be a string, low-key. The length of cur. And we would just append current. So they use the index. Index and current, right? So this would be 0. Could work with the first element. And this would be cur, right? The length of cur is equal to the length of digits. We res.append cur, we return, right? Then we loop through. Okay, for letter in phone letters letter. What we have to do here, we'd have to do, well, cur plus or equal to letter. And then we'd probably have to backtrack I plus 1 plus 1 cur. We would return res, right? Can I access local variable letter? Index is equal to the length of digits. Res.append cur, return. Full letter in phone letters letter. That's what we missed. Digits. Letter. So we actually get a value. Letter's not a value. Cannot access local variable letter where it's not associated with a value. What am I missing here? You're really close. 2 key issues. Incorrect looping. Index. Maybe it's meant to be code plus letter. We have to reassign a code is equal to code plus letter. Why are we getting D, E, A? That was why. If not digits, we would return an empty string. Okay. Co is equal to, so co. So why is this wrong? Seems like it's the same thing. Okay. It's carried over into the next iteration of the loop. That's why it doesn't like this one. That's why we have to pass it in here. Okay. Okay, we're going to call it there. I appreciate you guys watching, and I will see you guys tomorrow. See you later.